Okay, recording, cool. So before I actually explain what we're doing this week, I wanted to explain something that you did a couple weeks ago that we didn't really get to talk about again after I graded it from you guys, and not many people were able to actually do this one. So I just wanted to look at it really quickly so you guys can get the chance to fix it. So it was this acid rain table. So the instructions lead to create a scatter plot with SO2 as your y-axis and pH as your x-axis. So if you do that, you have your x-axis here, so that would be pH, right? That's our x-axis, and SO2 as the y-axis. So in order to do that, you would actually need to look and find both of these things from the map. So I'll show you really quickly. Hold on, let's see if I can make this work. There it is. Can you guys see that?
Yes.
Okay. So, for example, if we you get a basic idea of what we're looking at. So, talking about crude oil just means like it's not been processed yet. So this wouldn't be like the oil you go to the store and get. This is what it would look like if you found it in the earth, right? Crude, it's just plain not processed yet. Like if you use crude language, you didn't filter it at all, you just said what you thought, right? The crude oil is just there as it is. That's what it looks like. So obviously we weren't there when it formed, but it is made from hydrocarbons, which means probably came from something organic. So could have been that it was things buried at one point, right, and put under a lot of pressure and deposited deep underneath the rocks of the surface. So we know that it's underneath the rocks. We have to drill down and to under the rocks and actually bring it back up to use that oil. But when you bring it up, it's kind of a mixture of all of these hydrocarbons. So we talked about alkanes and alkenes last week, made of carbons and hydrogens. They're all different based on how long their carbon chains are. But if you get crude oil, a lot of times it's all mixed together. So it's not like pure butane or pure propane. It's going to be a mix. So in order to actually use it, we want to split it into its different like parts. So we use this thing here. It looks like a big tank, but it's called a fractioning column. It's fractional distillation. If you guys remember when we used distillation with the essential oils, it basically means that you heat it so it evaporates, it becomes a gas, and then later it will condense again. But in this one, it's a little more complex because everything is evaporated, but then it condenses based on its boiling point. So if it's something that needs to be really, really, really hot to boil and turn into a gas, as soon as it hits these pieces here, it's going to condense. What's that, Liv?
No. I was talking to someone.
That's your asking question. That's all right. So if it has a really high boiling point, as soon as it comes here, it's going to condense again, and it will kind of basically drip out of the system. So it'll condense and then it will come out. And these are the more thicker fuels. So it says high viscosity. That means it's almost like thick. Like if you were to pour out honey, right? It's thicker like that. That's viscous. It doesn't burn easily, so it takes a lot more to actually burn it and use it. But it's used in like power stations, and things like that, chips maybe. And the carbon chains are very, very long. So it's not just like one or two carbons, there's a lot of them. And then going up, these ones have a little bit lower of a boiling point. That's like diesel. Going up, you have kerosene, paraffin, things used for aircraft fuel. So you can tell stuff is sort of getting lower boiling points, smaller. Right. The next one is naphtha, which makes chemicals. Petrol, which is what you use in your car. So the boiling point is pretty low. So if you were to go fill up your car, you can smell the gasoline, right? You can smell the petrol because some of it is actually starting to evaporate. And then the top one are things that can be bottled. So like in the lab when we have the Bunsen burners, those things underneath, those are butane bottles. So those are actually here. You can also burn these ones, right? So yeah, those ones would have the lowest boiling point because at room temperature they would be a gas, right? That's how they are split, is based on their boiling point. And the top ones have smaller molecules, less than bottom ones have more. But it turns out that these top ones up here are actually the ones people use the most, even though when you put your crude oil into here, you get a lot of the larger molecules. So if we want to actually use it, people will take those larger carbon molecules, hydrocarbons, and they'll break them. So how they can do that is called cracking. So it's almost like cracking a pencil. I'm not going to crack my fancy pen, but cracking it, right? Breaking that long hydrocarbon into multiple pieces. And that's good because if there's so many long hydrocarbons no one's using, it makes sense that we could split them into the smaller ones people actually want to use. So a way that they do this is by putting some of those long chain ones here, and they add a catalyst. So when they heat it, it evaporates, and some of it will come down to the bottom of the tube. And because the tube is sitting in cold water, some of it will condense and become a liquid. And those are some of the alkane hydrocarbons. But some will still say a gas, so they will come up this tube and they'll come over here. And those are the alkenes that are short chain. So they can actually split it this way just by heating it up with a catalyst. And that's called cracking. So our alkanes and alkenes, we can crack them to make them smaller, or to use them to get heat from the bonds, you could do combustion. So the combustion reaction is just like any burning, you need oxygen, mix it with the hydrocarbon, and you get CO2 and H2O. So you have your reaction here of cracking with your larger chain to your shorter chain. So if you'll notice, 10 carbons was split. So it could be split anyway, right? 5 and 5, 4 and 6. Here it happens to be split 8 and 2. So the hydrogens would also be divided into 18 and 4. And if you remember the formulas from last week for alkanes and alkenes, you could figure out whether this was an alkane or alkene, or you could try to draw it out. Right? C2H4 would have to have the double bond between the carbons, making it an alkene. So here's your example. If you start with C12, it breaks into C2, C4. What will be left? There'd be 6 carbons left. It says there's 2 of them, so it would need, each one will be 3, right? So C3. And then hydrogens, take away 4, that makes 22. Take away 10, that makes 12. So if there's 12 hydrogens left, we split it between 2 molecules because you see the 2 here. That makes H6. So C3H6. You can check that down there. And that's how you figure out a cracking equation. We already talked about last week how to tell if it was an alkane or an alkene and mix it with bromine water. If it's an alkene, it will become colorless. If it's an alkene, it will remain colored in the bromine water. So that is that. just a reminder, a little mind map for you of some of the things we've talked about in organic chemistry. Crude oil kind of is the basis of how we've looked at organic chemistry. So how is it formed? How can it be divided up through fractional distillation? And what are some of the properties and uses of each fraction? And then hydrocarbons, we talked about this a lot last week with the alkanes and the alkenes. There's also alkynes, but we mainly worried about these two. Combustion, they're reacting with oxygen, and cracking is how can we break it. So we'll answer these questions next week, but there's a look for you if you want to get started on them. And do you guys have any questions for me?
Not really.
Really? Did you learn any of
Will you like
Oh, go ahead.
upload the recording?
Oh yes, I will upload the recording.
Okay. I mean, in case if like I forgot or misunderstood something,
Yeah,
then I could.
Yep. And for all the people who weren't here too. Did you learn any of this for WSC?
I don't think so.
Not yet. Yeah.
No. This is so different.
Yeah, lots of different stuff to learn.
WSC science last year was technology. So it was batteries and positive and negative charge. I still remember a bit.
Good. Well, this broadens your knowledge base then. So,
Yes.
thanks for coming, guys, to our last Monday meeting. You'll still have to come to the Tuesday night one, so I get to see you again. But yeah.
Okay.
All right. Good to see you guys. And have a good day.
Bye, Miss Hannah.
Okay.
Bye.
There's one thing that you are lacking.
What's that, Vincent?
There's one thing that you are running out of at your place.
What's that? Toilet paper. So far, not yet. But I appreciate the gesture of making me jealous if I was running out of it.
Okay, bye.